Today we're talking about modeling trig functions. Let's go back and remember our two formulas. Make sure that you have these written in your notes. Our sine function and our cosine function. Remember, A stands for amplitude. 2 pi over b is our period. That tells us how many radians it takes to complete one cycle of our graph. The inverse of that, b over 2 pi, is our frequency. That tells us how many cycles for every 2 pi radians. C is our horizontal shift. If we subtract 2, we're going to shift our parent function to the right 2. If I have a plus 2 inside the parentheses with x, I'm going to shift my parent function to the left 2 spaces. And finally, vertical shift is how far up or down we're going to move our graph from the parent function of sine of x or cosine of x. D also helps us find our midline. So let's take this equation and let's create a graph for it. This is just going to be a rough sketch. It's not going to be perfect, but that's okay. As long as we can approximate it, we're going to be in good shape. So from this equation, we get an amplitude of 2, a midline of y equals 3, and a period of 2 pi. And here's our coordinate graph. Notice our y-axis is in regular units, and our x-axis is in radians. So I'm going to first put in my midline. Then I'm going to use the amplitude to put kind of boundaries for my graph. These boundaries won't go beyond 2 units above my midline or 2 units below my midline. Then I'm going to create a border for a cycle. Since the period is 2 pi, that means that from 0 to 2 pi is going to complete one full cycle of my graph. So, since this graph does not get shifted left or right, I do not have a c added or subtracted to the x value inside the parentheses. That means that on the y-axis, my graph is going to hit that midline because that's what the sine function does. So then at 2 pi, since that's one full cycle, I'm going to be right back at my midline. Halfway in between the two endpoints, I'm going to be at the midline again because the sine function goes up, then comes back down, then ends the cycle. So halfway between the left point and the middle point, I'm going to be at the very top of my graph. And halfway between the midpoint and the right, I'm going to be at the bottom of my graph. And in between, since this is just a rough sketch, I can start to create my sine wave. This is not going to be perfect, but in this case, it's okay. We're just doing a rough sketch today. And then of course I could continue that pattern, This is going to continue to go down, I could put those same points on the right hand side or on the left side of my graph and create another full cycle to my sine wave. Oh, that looks horrible, but hopefully you get the idea. If I put this in a calculator and look at what it's supposed to look like, here is my sine wave. And just from those little pieces that we put in, we came super close to being a perfect sine wave between negative 2 pi and 2 pi. The cosine wave at the y-axis does not hit at the origin or doesn't hit your midline on the y-axis. This is the parent function to cosine. Notice how the maximum for my parent cosine function is on the y-axis. So just so that we're aware of that difference, let's try graphing a cosine function. here's the comparison between cosine and sine, right? Midline versus maximum at the y-axis. So let's try graphing this cosine function. We need to get some information from it. In this case, our amplitude is 2, our midline is at y equals 1, and our period again is 2 pi. The coefficient on x is 1, so 2 pi over 1 gives me 2 pi. That means that it takes 2 pi to complete one full cycle again. So on my graph, I'm going to do the same thing. I'm going to put in my midline. I'm going to use my amplitude to put in my max and my min. Then I'm going to put in some boundaries to complete one full cycle. I'm going to keep that in mind. Okay. Now for cosine, since this graph does not get shifted left or right, which on today's assignment none of them are going to be, instead of putting a dot at the midline, remember on the y-axis, on a cosine function, my maximum is there. And again at 2 pi, since that's going to be the end of my cycle, my maximum is going to be there again. Now this time, remember a cosine function starts angling down from the y-axis. So I'm going to go down, and to get to my cycle, this is going to be my halfway point. This is going to go down, and then it's going to come back up. So at the midpoint, I'm going to be all the way down to the bottom of my graph. Halfway in between the left point and the midpoint, I'm going to be on my midline. And again, halfway between the middle point and the right-hand point, I'm going to be on the midline again. And then I can start putting my cosine curve in place. Remember, they're not straight lines. Make sure that they're kind of curving around. And I can repeat it again on the left-hand side of my y-axis, right? I can put in my end point, my midpoint, and 2 points in between where I hit the midline. And then I can draw in a rough estimation of the cosine curve. If I put this on a calculator, I have a pretty good estimation of what that cosine curve would look like. So in this assignment, you're going to see a few different things. You're going to have to compare two graphs to see maybe which one has a greater amplitude. You're going to be comparing periods to see which one is greater, right? If I'm asking for which one is greater, you're saying which one's wider, which one takes longer to complete a full cycle. You're going to write the equation from a graph. So using amplitude, midline, and period, you're going to have to write the equation from a graph, and you're going to graph the function from an equation. Finally, you're going to graph a function and determine where the maximums, minimums, and zeros are. Zeros are where your graph hits the x-axis, right? Those are x-intercepts. Good luck. Make sure to write down any questions that you have. Take the online quiz, and don't forget to bring your written notes to class. Screenshots do not count. I need to see written notes. Have a great day. You are awesome, and I will see you later.